Welcome back. The AWS cloud, like any large and complex environment, is built on top of a stack of rules and assumptions. The success of your AWS projects will largely depend on how well you understand those rules and assumptions and how you fully adopt the practices that they represent. The AWS shared responsibility model is a helpful articulation of those rules and assumptions. It's worth spending some time thinking about it. Amazon distinguishes between the security and reliability of the cloud, which is its responsibility, and the security and reliability of what's in the cloud, which is up to you, the customer. The cloud itself consists of the physical buildings, servers, and networking hardware used by the AWS data centers. AWS is responsible for making sure that its locations are secure, reliably powered, and properly maintained. AWS is also on the hook for patching, encrypting when relevant, and maintaining the operating systems and virtualization software running its physical servers, and for the software running its managed services. But that's where things can get a bit complicated. What exactly is managed and what's unmanaged? So here is the AWS shared responsibility model, right? So the customer is responsible for what's in the cloud, the customer's data, user applications and access management to the application, operating systems, network and access configurations, and even data encryption. AWS is responsible for the cloud itself, the hardware and the network maintenance, the AWS global infrastructure, and any managed services. A managed cloud service will hide all or some of the underlying configuration and administration work needed to keep things running, leaving you free to focus on the business end of your project. For example, an application running on EC2 might need a database in the back end. You can install and configure a MySQL database engine on an instance in EC2 by itself, but you'd be responsible for patches, updates, and all the regular care and feeding, not to mention letting it out for its morning walks, right? But you'd be responsible for the database if you installed it on an EC2 instance. Alternatively, though, you could point your application to a standalone database that you launch on Amazon's RDS service, or Relational Database Service, RDS. AWS is responsible for patching any RDS databases and ensuring its data is secure and reliable. You only need to worry about populating the database and connecting it to your application. RDS, therefore, is a good example of a partially managed service. How would the next level of managed service work? Look no further than Elastic Beanstalk. This hides just about all the complexities of its runtime environment, leaving nothing for you to do beyond uploading your application code. Beanstalk handles the instance, the storage, the databases, the networking, all those headaches, including ongoing patches and administration, making that all invisible, all behind the scenes, and you just bring your code. So that is a more fully managed service, is the Elastic Beanstalk. So unmanaged resources, the most obvious examples of an unmanaged service is EC2. When you launch an EC2 instance, you're expected to care for the operating system and everything running on it exactly the way you would any other physical server in your on-premise data center. Still, even EC2 can't be said to be entirely unmanaged, since the integrity of the physical server that the host is on is, of course, the responsibility of AWS. Think of it as a sliding scale rather than a simple on-off switch. Some cloud operations will demand greater involvement from you and your administration team, and some will demand less. Use this simple rule of thumb. If you can edit it, you own it. The key, especially during a project's planning stage, is to be aware of your responsibility and to always make security a critical priority. Service health status. As part of its end of the bargain, AWS regularly updated region by region reports on the status of its services publicly makes this available. Any service outage that could affect the performance of anyone's workload will appear on Amazon's Service Health dashboard. So you can go to status.aws.amazon.com. Often with a minute or two of the outage hitting, it will appear on the status page. While configuration errors are always a possible cause of a failure in your infrastructure, you should always make the Service Health dashboards one of your first stops whenever you dive into a troubleshooting session. Right, just make sure that it's not already a known issue. So let's go check out. So we can go here to status, HTTPS status .aws.amazon.com. Alright, and so no adverse attacks are known to exist right now currently in any of the service in the North America regions. So as you can see, there are quite a number of services. Wow, there are just a ton of them. But all right, so you can see that if anything were out, you would go here and it would show that there was an issue. But right now, everything looks good. Everything is green. There are no outages. But so that's status.aws.amazon.com. And because they're so easy to scale up, cloud computing services are powerful tools for accomplishing things no one had ever dreamed of just a decade ago. But for the same reason, there's also potential weapons that can be used to commit devastating crimes. The AWS acceptable use policy makes it abundantly clear that it does not permit the use of its infrastructure in any illegal, harmful, or offensive ways. Amazon reserves the right to suspend or even terminate your use of its service should you engage in illegal, insecure, or abusive activities, including the sending of spam and related mass mailings. Even running penetration testing operations against your own AWS infrastructure can cause you trouble if you don't get explicit permission from Amazon in advance. You should take the time to read the document and keep its terms of service in mind as you deploy on AWS. Got a typo there. Alright, I'll have to fix that. So let me just fix that. Alright, so alright, so aws.amazon.com/AUP, get the acceptable use policy, and basically, like it said, is just don't do anything illegal with AWS. So that ends our lesson 4. In the next video, let's see, we're going to pick up lesson 5, and that will cover securing your AWS resources. So we'll see you in the next video.